Today in pre-cal we are talking about the inverse trig functions, the main three we started talking about yesterday. We kind of did a little trifold paper, so we're going to start with the inverse sine, then we'll do the inverse cosine, and lastly the inverse tangent. Okay, to be able to do that we're just going to start with sine. So if y equals the arc sine of x, or y equals the sine inverse of x, our domain is from -1 to 1. Our range, we talked about this yesterday, this should all be review, is from -pi/2 to pi/2. Again, that's happening because I have to cut it off for it to be 1 to 1. To see what my graph would look like, I could look at my original graph on that domain of regular sine. This time I'm flipping my x and my y axis. So now my x-axis, is -1 to 1, because that used to be my range, now it's my domain. My range is pi/2 and -pi/2, or from -pi/2 to pi/2. And if I look at my graph, at -pi/2, I'm at -1. At 1, I'm at pi/2, and at 0, I'm at 0 for sine. So my graph looks something like this. And it does have some curvature here, so try not to draw it just like you would y equals x. There is some curvature there. Okay, we'll look at an example of that as well. So example number 1, we'll want to look at some of the transformations. Y equals the arc sine of 1/3 x plus pi/2. Okay, now before, the b, or the number right here, changed our period. That's still happening. It's changing our x-axis, okay? And so instead of thinking of changing our period, we're going to think of changing our x-axis. To do that, we're going to multiply our x values by the reciprocal. So we do have -1. That's our original. We're going to multiply that by the reciprocal, which is, of 1/3 is 3, and 1, that would be this one times 3, would be -3 to 3. Okay? Also, this piece right here, this pi/2, is going to make us move up by pi/2. Remember on the end, we're always talking about moving up. So what used to be at -pi/2, sorry, that's not in your view. What used to be at -pi/2 down here is now at 0. What was at 0 is now at pi/2. And what was at pi/2 is now at pi. So our low point is here, our high point is here, our middle is in between, and we draw our curved line. And yes, we are going to have to learn the transformations for these. Okay, the next one that we want to look at is our inverse cosine. We start with y equals the arc cosine of x, or the y is the cosine inverse of x. The domain is, again, -1 to 1. The range, remember from yesterday, is from 0 to pi. That's what makes it able to take an inverse. And so if I draw my graph, I want to go from -1 to 1 on my x-axis. I want to go from 0 to pi on my y-axis. Halfway in between that, of course, is pi/2. And if I look, I will start at -1 and 1. And halfway in between, I will go through. And I kind of want a curve shape when I do that. Now, if it will help to think of it this way, it's going to confuse you to do it this way. Think of it like this. At 0, we're at 1, okay? And at pi, we're at -1. That's still true of cosine, okay? All right, that's our original. Let's think about how to transform that. So example number 2. Y equals 2 arc cosine of x. This 2 right here is going to change our kind of amplitude, so this y value stuff. So I'm going to start with my 0, because that was my lowest value. I'm going to multiply that by 2, and I still get 0. I'm going to take my highest value, my pi, multiply that by 2, and 2 times pi is 2 pi, so that's how that's going to change that. Nothing has changed about my -1 and 1. I go from 0 to 2 pi. Halfway in between would be pi. I'm going to start with a mark here and here. And I go right through. Should look very similar here. The final graph that we need to look at is the inverse tangent. That's the y equals the arctangent of x, or y equals the tangent inverse of x. The domain is from negative infinity to infinity. The range is from negative pi over 2 to pi over 2. And if I think about my graph, my asymptotes that used to be vertical asymptotes are now going to be horizontal asymptotes. I'm going to draw my x and y axis. I want to put negative pi over 2 on here. Those used to be when they were sideways. Let's go this way so you can think about it as negative and positive. I would have asymptotes there for tangent. That's still true, except now we're turning it sideways. These are now horizontal asymptotes. Also at negative 1 and 1, I had some kind of points here. We never really called them, or we weren't trying to call them the amplitude. But this goes like this. And it hugs those lines just like it did, just like tangent did before. Okay, it's so hard to show you this way because we're talking about negative, and then the positive would be here, and it would look flipped, so it's kind of hard to show you how it's switched around. But anyways, that's how the tangent would look. It hugs these lines, okay, hugs these asymptotes, and goes on forever. That's why our domain is from negative infinity to infinity, and our range is from negative pi over 2 to pi over 2. Let's look at a transformation of this. Y equals the arctangent of 2x. Remember, 2 always changed our period, so here we're going to change our little values here. To do that, we're going to multiply by the reciprocal. So I'm going to do 1. The reciprocal of 2 is 1/2. 1 times negative 1/2 is negative 1/2. 1 times 1/2 is 1/2. So when I draw, I'm going to put my marks at negative 0.5 and 0.5. I'm going to leave my pi over 2 and negative pi over 2 asymptotes. I'm still going through my center here at 0, my points of interest here. And I'm going to do my best to draw a curve that hugs my asymptotes. And there's that right there. Okay, on the back side, the thing I want to show you is how we're going to use our original formula that you've gotten so used to so that I can mark each piece. Okay, so we're going to have y equals a sine inverse b of x minus c plus d. You've become very familiar with that. Notice I have sine inverse, or sine to the negative 1. That could also be cosine inverse, tangent inverse, arc cosine, arc sine, or arc tangent. The a changes my upward stretch or shrink. For it to be a stretch, it would be something like 3, a shrink, something like 1/3. Okay, vertical stuff always is like you think it should be. B is going to change the width of my graph, which used to be the period. Now we're going to call it the width. If I have something like 2, I multiply my negative by 1/2 and my positive by 1/2. And I should get negative 1/2 and 1/2. I multiply by the reciprocal. If I start with something like 1/2, I'm going to multiply by the reciprocal and get 2 and negative 2. It doesn't matter for tangent because we're just talking about it going on forever for tangent, so that's not as big of a deal there. For C, we're talking about a motion left or right. And for D, we're talking about up or down. Of course, with left or right, the left would be the positive, the right would be the negative, the up would be the positive, the down would be the negative. That should be familiar to you. Really just that A and B is kind of changing. And it's not changing what it does, it's just changing how we think about it. Let's look at one more example of a transformation. Example number 4. Y equals 4 over pi tangent inverse of x minus 3. The minus 3 tells me I'm going to move right by 3. The 4 over pi tells me that I'm going to multiply my vertical stuff by that number. So I'm going to do my pi over 2, which would be my high point for tangent, times 4 over pi. And the pi's will cancel, and 4 over 2 is 2. That's my new high. My low, negative pi over 2 times 4 over pi. Pi's cancel, and I've got negative 4 over 2, which is negative 2. My low is now negative 2. And I've moved to the right 3. So when I draw this, I'm going to draw my x and y axis. Again, my high is 2, my low is negative 2 because of this piece of the transformation. Before, I would have done negative 1 and 1, so I do that, negative 1, 1. And I've got to move right 3, so I'm doing 1, 2, 3, I move over 3, 1, 2, 3. So my new point here will be 4. My new 0 is 3, so I'm going to put a mark here, mark here, mark here, my asymptotes, and my graph that hugs those asymptotes. So I moved over by 3, my 0 moved over 3, this point moved over, this point moved over, and my height changed. And that's all for that. Now these are hard. I know you don't like graphing, but you need to give this a shot, see what you can do here. The homework is page 350, and you're going to do numbers 78 to 86 even. Not a whole lot of problems, but just a few for you to try. Good luck. Let me know if you have questions.